Hello YouTube. I decided to try a different transistor. So this is my tried and true 2N3055 transistor. I really love this transistor, you see it in all my videos. But I decided to go ahead and try a different transistor out. And this one is 2N5630. Its frequency is 5 times higher than 2N3055. So I thought it was going to be better at high frequency applications like joule thief circuits. So I decided to test them head to head. So this here is a 12K potentiometer, and at the bottom is another one of these 5630 transistors. And this here is a pod core. It's 47 millimeters by 45 millimeters, and I did something different with it. So here's the basic schematic of what this thing looks like. So we have two layers in there at the beginning. So one layer is clockwise, the other layer is counterclockwise. It's 23 gauge wire, and on top of that we have another layer, and this one goes counterclockwise back and forth, and then back, and then we have another layer that's clockwise. It goes back and forth and then back. So we have 2 layers, and then 3 layers on top of that, and then 3 layers on top of that. And this is the part that goes to your transistor. And these are just other layers in there, and they're shorted out at the top. I shouldn't say shorted out, connected at the top. And your AC is would be located at those other layers, those 3 layers. Okay, I'm gonna let you guys check out the schematic once again. It's basically the same as a joule thief circuit, but with extra additions. So clockwise, counterclockwise, connected together, then clockwise, counterclockwise, connected together, and then that's gonna be your output. Okay. So I have a little load here, my 5 watt light bulb, and we have voltmeter. So I'm gonna turn the whole thing on, and then we can see the voltage. Okay. As you can see, the light is really bright. I'm gonna turn off so you can see. See, I turn off the light, but you can still see perfectly with this light. And our voltage is, let's see, should be around 50 volts. One of the connections is acting up because I'm using these alligator clip connections, so we're getting a little bit of resistance somewhere. But anyway, it's 50 volts under load. See, I'm going to unscrew the light bulb, and then we can see the voltage then. So let's see. Should be around 66 volts. Let's see. Again, one of the alligator clip connections is acting up. But anyway, let's say it's 60 volts, okay? And this is with this 5630 transistor. So now I'm going to switch out the circuit for my tried and true 2N3055 transistor, and then we can see its performance. Okay, so I went ahead and switched out the 2N3055 transistor, and it's the same circuit as before. So let's see how it performs. So voltage without a load is 47.3 volts. So I actually had to adjust the potentiometer because to obtain the highest voltage possible. See, if I mess with the potentiometer, voltage will be different. So you're trying to get the highest voltage possible. Okay, so it's about 47 volts without the load. Let's see, with the load. It's 43.1 volts. The light bulb is extremely bright still. So I don't know, you guys, to sum up the results of the experiment, the 2N3055 is comparable to this transistor. I mean, this one will give you a slightly higher voltage, but in terms of light, I couldn't perceive a difference between the two transistors. So if you want higher voltage for some reason, this would be better, but otherwise I guess just stick with your 2N3055. Anyway.